Today's lesson is over 6.6 using proportionality theorems. Now, these are theorems that come straight from triangles being similar, generally by angle. So, looking here first, we've got 6.4, the triangle proportionality theorem says if a line is parallel to one side of a triangle, intersects the other two sides, then it divides the two sides proportionally. So, for example, here, seeing TU is parallel to QS, that's going to give us similar triangles, right? These angles congruent by corresponding, so are these two, right? And we even have a reflexive third, right? So the triangles are similar, but more specifically, these side proportion-wise have the same proportion or ratio, as SU and UR. And so that's what we have here. RT to TQ is equal to RU to US. Okay. Next one is opposite, right? If the sides are proportional, if those two pairs are the same, right, they're going to equal the same ratio, then we can add the parallel arrows or triangles. So solving, we've got solve for QR. So you can leave it as QR, you can write it as an X, but we've got those parallel sides, so we can do X over 9 equals 4 over 6. Cross multiply and divide, we get 6X is 4 times 9, so divide by 6 on both sides. 36 divided by 6 gives us X equals 6. Or, by the way, that was QR. Right? I just called it X for short, so QR is 6. Next, along the converse line, right, determine if they're parallel. So again, we're doing the same idea. We're saying 90 to 50, does that equal 72 to 40? Right, we're not sure, we're checking. If that makes it equal, then we're good. So just cross multiply or simplify. This is 9/5. And then divide by 8, divide by 8. I get 9/5 over here as well. So they are equal, and so yes, those lines are parallel. Next, we've got a couple more. Now, in this case, we've got 3 parallel lines that are intersecting 2 other not necessarily parallel lines, right? And how they intersect them makes these equally proportionate, right? So 3 parallel lines intersect 2 transversals, then they divide the transversals proportionally. And again, notice I didn't use congruent marks, I kind of use squiggly because they aren't equal, they're proportional. UW over WY equals VX over XZ. Okay. Sitting here. The next one says if we have a ray bisecting the angle, right? So again, angle bisector of a triangle, then it divides the opposite side into proportional length. So if we have an angle bisector AD over DB, those two, let's label it this way, X over Y, going to be equal to, we're going to go W and Z. And that's how it's going to work. Now, using our proportion rules, we could also say X over W equals Y over Z, or W over X equals Z over Y, right? There's a ton of different ways you can say it. So just try to memorize which way works best for you. Because of how proportions work, as long as it's true statement, right? Like we can cross multiply or use some of those 6-2 rules, it will be equally true and valid. Next, find the length of YZ. Okay, we've got 44, 35, 36, and we don't know. So 44 to 35 equals 36 to what? Now 44 and 35, not nice numbers. So we may not end with the greatest value here in the end. But 44x equals 35 times 36. Divide by 44 on both sides. They both have a 4 in them, so divided by 4 I get 11. Divided by 4 I get 9. And then we get 9 times 35 over 11. So doing a little calculator, we end with 315/11, which is Found 28.6. One here. So 28 times 11 gives us 308, so that's 711. 28 and 711. Sometimes they're not the greatest numbers, especially as they move beyond our typical lower, 0 to 20 numbers. Next, find the length of RS. Now notice, they give us X for RS, but they give us QS, but based on our proportion used those four sides. We're missing this QR here, but they give us 15. So QR is going to be 15 minus X, right? X plus QR is 15, solving for QR with minus 15 to both sides. Again, segment addition postulate idea. If I want to have a value for QR, right, this is the math I just did, right? And that's why I wrote that there. But that is only for setting up the proportion. So now we have, based on that previous theorem, right, this last theorem here, right, we can set it up a couple different ways. We will set it up how they had 15 minus X over 7 equals X over 13. Cross multiply and divide. 13 times 15 minus X equals 7X. We get 13 times 15. I got 195 minus 13X is 7X. Plus 13X to both sides to get 20X equals 195. And again, not always a nice number here. Divide by 20, a little less than 10. I get 9 is 180. I get 9 and 3/4 is X, or 9.75. You can always plug that back in here, right? We can always plug it back in there to see if it works. Should always, technically there's two spots, right? There and there. We plug it back in to make sure it would work. And we would get something like 5 1/4 over 7 equals 9 3/4 over 13. It actually looks okay by the eye test. Next, in the diagram, angle 1, 2, and 3 are all congruent, and GF is 120 yards, DE is 150 yards, and CD is 300 yards. Find the distance between main and south main. Okay. So they're actually looking for this distance here. It says HF. We're going to need this distance here first. Okay. Now, angles being congruent seems a weird thing to give us, but corresponding angles congruent give us parallel lines. These lines are all parallel, and it is that first theorem they gave us earlier, where if we have 3 parallel lines going through 2 transversals, then they are proportional. So we've got this proportion going on. 150 over 300 equals 120 over X. Right? Quick simplifying here. This is 1/2. So if this equals 1/2, 2 times 120, X is 240. And now double check, is this HF? No, it is not. 240 is right down here. So my answer is 240 plus 120, which is 360, and the label is yards. So make sure you are double checking that if you're doing a word problem, that your labels match. And that you're solving what they asked for. And that's important. Well, more simple version of this. Go ahead, try it on your own. Pause the video and try it. And here's the setup. And this equals 5, 6. And I'm already realizing the numbers aren't going to be great. So 5 cross multiplying, again, this equals 16 over y. So 6 times 16 equals 5y. Divide by 5, and I get 96/15, which is going to give me 19 1/5, or 19.2. No labels, but there's my answer for AB, or I called it Y. Call it AB. And again, make sure you're answering correctly. there are times where they may even, you know, like I said before, add the C here and ask for CD. We can still do the same math and figure it out. One more time on the bottom, solving for AB. We've got 4 root 2, 4, and blank. So this is the equation I have. 4 over 4 root 2, does that equal 4 over what? Okay, now this one, the tops match times 1, right? The bottoms are going to match. So AB is 4 root 2. It looks like you're going to have some hard math to do, but if you just look at what we have, it's going to match. They're going to be the exact same. So AB is going to equal AC, which is 4 root 2. Moving on to some challenge ones. Now these, I did my best to draw these to scale. However, the diagram wasn't drawn to scale. So looking at the fact that they say, show that angle triangle, GEC is isosceles. It is not isosceles in the way you think. The base angles are angle EGC and ECG, meaning these are the two angles we're going to find congruent. Now looking at the diagram, this one is all about the parallel. Okay, so these are parallel, therefore these angles here corresponding, and so they're both equal. So we've got the 2 mark there, that is 2 mark. Now these two angles are alternate interior, so those are also equal. So I know it doesn't look isosceles that way, but there we are. We have 2 angles are congruent with base angles theorem. Therefore, triangle GEC is isosceles. So writing it out a little bit, angle EGC congruent to angle FED, and angle ECG congruent to angle, that one was the DEC, I believe. This one was alternate interior angles. The top one was corresponding angles congruent. So it's isosceles. And technically then, you know, we've got these two are equal, even though, again, based on the picture, it doesn't look the greatest. Next, show AB to BC equals EA to EC. Okay. So they're saying these two are equal to these two, the EA to EC. So here's all you're doing here. With this one, these are angle bisectors. So this is using that angle bisector to say AB to BC equals EA to EC. Again, if we slide back a couple slides, it's almost, yeah, it's this theorem to a T. Okay. Okay, that theorem to a T. So we're just using that theorem, right? Forgetting about names, they don't give it a name. So it's, again, you're using that triangle proportionality per se theorem, right? Angle bisector theorem per se. Sides proportionally cut, right, by our angle bisector. Sounds a little odd, but that's actually what that theorem was. One more problem and a plan to prove, and then wraps up this lesson. So we've got, if angle dead is a right angle, EB is 3, EB is 8, what is BD? Okay, so they're saying if this is a right angle, and they gave us some values, we've got this one's 3, this one's 8, what is BD? Again, if you just redraw it, right triangle, 8, 3, what is this value for BD? Pythagorean theorem, right? 3 squared plus 8 squared equal BD squared. Square root both sides. 9 plus 64 is 73. So the square root of 73 is BD. That'd be right between 8 and 9, probably like 8.5-ish. Last one. And I switched it to a plan to prove because it's not a quick and easy proof like it looks. So this is the first theorem we went over today, and the plan to prove is going to be, we wanted to show that the large triangle, QRS, is similar to the smaller triangle that's also inside of it, TRU. And we do that by saying these corresponding angles are congruent, right? Q is congruent to angle RTU. Because there's more than one angle at this vertex, you got to use your letters. Same thing with S and what we would like to call angle U, but it is TUR. Right? So that gives us angle. And this is where it gets tricky. You would like to say this comes from similar triangles, but it doesn't. So this is the last little piece I'm going to show you here. From these triangles, we could say QR to TR is equal to RS or SR to UR, right? Now that's close to this, right? But what's missing is our numerators are a little messed up comparatively, right? Looking at what I just circled there. Our numerators are off. So what you want to do is, what is QR? What is SR, right? This is technically segment addition. Well, QR is QT plus TR, right? And we're still over TR. And SR is SU plus UR. So I got to go up and down quite a bit there. And this looks an awful lot like Rule 4 from 6.2. Proportion rule. They added the denominator to the top. So we're going to go the other way, and we're going to take the denominator away to get QT over TR equals SU over UR. Now, mathematically, we could have also done that for those who think that's a little bit of a shortcut. We could have also subtracted one from each side, which would have gotten rid of, pardon me, the TR and the UR. And that wraps up today's lesson. Homework is posted on Google Classroom.